My name is Johannes Stiehler. I'm CEO of a company called ayfie, which is a company that deals with natural language text only. Actually, that is our core business. And what we do is essentially applying natural language processing to real life problems. So I'll be telling you a little bit about how we do that, what natural language processing actually means, what it can achieve, and how you can use it in simple and more complicated ways. I'm going to start up with a very quick intro into what our company is producing based on that, so you understand the context of why we're researching and programming in that area. Then I'm going to show you some of the fundamental principles of natural language processing, what you can achieve, where you can take it, and then I'm going to show you some practical application on an example that has nothing to do with a kind of a business purpose. So it should be a little more fun than the usual. So who is ayfie and what do we do? We are working to uncover truth through intelligent text analysis, which I know sounds grand, but essentially what we're doing is we're dealing with large corpora of unstructured data. So Word documents, emails, chat histories, all types of content where natural language is the dominant form of the content. And we do that in the interests of justice, integrity, and privacy, which means we work in litigation, we work in PII detection, data breach notification, these kinds of problems where you basically rely on natural language processing and natural language analysis to be able to deal or handle large volumes of data that you could otherwise not access. Well, that you would have to go through manually. We're distributed in Europe and the USA. At this point, we have a presence in London in the Barclay Labs. We are developing and researching in Oslo and Munich and Gliwice, and we have professional services and sales in New York and Denver. At this point, we have two products, both of them based on natural language processing. Both of them apply the principles of that technology to make data accessible to the end users. ayfie Inspector is more geared towards analyzing, scrutinizing static volumes of data, such as you would get from a data breach, so basically an email box that is hacked or something like that. Whereas ayfie Locator is a suite of products aimed at collecting all the data that you have inside your company, analyzing it through NLP, and therefore enabling you to access it to discover knowledge, to discover experts, to assess risk. So basically, you can find where in your company silos you have PII, for instance, or certain types of documents, and enables you also to do early data assessment on your own data if the need for that arises. So two products, both of them based on analyzing natural language text, first and foremost, as we humans produce it. So naturally, because of that, we are investing a lot of time and effort into researching and developing natural language processing. We were actually founded as a merger of two companies in 2016, one of which was a startup here in Munich, centered around linguistic technology, and the other was an enterprise search company. So ever since then, we have worked to integrate natural language processing with search applications to make those applications more accessible for humans and to enable workflows that would otherwise not be possible. When we talk about natural language processing, there's often some other terms that are thrown around that are treated as being synonymous or otherwise related. Artificial intelligence comes to mind, machine learning comes to mind. So both of them are different from natural language processing. You can use machine learning to do NLP, but you don't have to. And artificial intelligence is usually seen as much broader than just NLP. So natural language processing is a field of artificial intelligence because it enables machines to expose some form of or exhibit some form of intelligent behavior that gives machines, namely computers, the ability to read, understand, and derive meaning from human languages. What does that mean? NLP is at work when you feed a document into a search engine. when you store a document on your computer, it's not at work because your computer will not look at the content of this document. But when that document is picked up by a search engine and indexed, such as the Office 365 search engine, then already it applies very basic NLP to make sense of this document and store it in a form where you can search for it and access it later on. In its proper use, that is a very basic level of NLP, you almost can call it that. Where NLP really comes into play is when it's about understanding the content of this document beyond simply being able to search for it. And then at the highest level, to derive meaning, which means to draw conclusions or reason based on natural language documents. So why bother? It's a very complex technology. It's sometimes not really that pleasant to work with, and there have been 50 years of research going into this. Why do people want to solve this problem of analyzing natural language in such a way that computers can understand it? Well, essentially, there's two reasons for that, two main reasons. One is when we reason inside our head, obviously we are already using natural language. So that is the easiest and also the most precise way we as humans have to convey our thoughts. So in a normal scenario, you want the computer to be able to understand your intent as closely to what you thought about as possible. In many applications where you're trying to convey your intention to a computer, through the lack of NLP processing, you have to go down to a very low level to express what you're looking for. If you think about searching on Google or Bing or any other search engine, you're basically, you have an intent in your head where you think about something that you want to find, but then you have to break it down into individual terms and even play and change those terms until the search engine comes up with what you were actually looking for. That is obviously not great for a human being because you have to do this translation stage. And the second reason is that because our thinking and our reasoning happens in natural language, over 80% of the content that we produce is free text, essentially. So over 80% is not structured, it's not spreadsheets or numerical data or facts that a computer can read and use as is. It is natural language content, it's Word documents and emails and things we talk about with our coworkers through Slack or other tools. So that part of the knowledge of a company, those 80%, oftentimes just lies dormant because the technology to access it, to make sense of it, to even find it is missing from the IT stack. And that's where natural language processing comes in and makes that data accessible to a certain degree to computers for further analysis. So for instance, it enables you to run business intelligence analysis on natural language reports that you might be getting from subsidiaries, or it might enable you to do predictive analysis based on service reports you're getting from your service workers. So that's why we bother. We want to interact with machines based on as much or as close to our own way of thinking as possible. And we want to get access to all that data that we produce and that we have produced throughout history that is still in natural language form. To give you sort of an image of how the language of these two entities, the human and the machine, differs, think about the simple intent of answering the question, do I know a senior manager in California? So normally you would probably go in your LinkedIn profile, you would scroll through a network and you would look for people who live in one of the cities of California and also have a title that hints at them being in senior management, which might be something like director, VP, EVP, SVP, CEO, CTO, something like that. If you want to convey that same information intent to a machine, you usually, in most search engines, cannot use natural language, but you have to resort to something called Boolean querying, which you can see on the right side of the screen, where you have to explicitly enumerate all the individual tokens, basically all the individual words that you want to find in documents that would capture your intent, your interest. So you would have to enumerate CTO or CEO or CMO or CSO or VP of or EVP of or, and then all the cities of California, essentially. So if you were to do it that way, you would end up to translate this one sentence in something that a machine can process on a, for instance, a search index. You would end up with the thousands of queries that are actually running in the background. And this way, the right-hand side has traditionally been how we interact with search engines, how we interact with research tools. We usually, and that is true in many areas of modern day life, we usually lower ourselves to the level of the machine. We rarely manage to elevate the machine to the levels of our own language and our own thinking. And natural language processing is a technology that aims at doing exactly that. Hence, you have Siri and Google Assist and other tools that you now can use natural language to interact with. Although, as people who try to use these tools might have noticed, we haven't come a really long way. It's not like these tools really understand natural language, but they're way better at parsing it than machines have been in the past. So we're getting at a higher level of natural language understanding in interacting with a search engine or a tool such as Siri. In the business world, there's also a lot of applications where this kind of natural language processing, text analysis would come in handy. If you think about a data breach where a hacker gains access to 4 million documents, emails, doc files, PowerPoint presentations, some of those might be marketing material that is public anyway. Some of those are maybe harmless email conversations or newsletters or something like that. But some of them will also contain GDPR relevant information, will contain people's personal data that should be protected through privacy, and where you have to essentially notify these people that their information has been leaked. So under GDPR, you're now actually regulated and obliged to do that. But reading through 4 million documents and searching for people's names and then trying to understand who you have to contact to inform them is obviously not feasible. So here NLP also comes into play and enables you to find the relevant documents and analyze them for the occurrence of people's names. And that is one of the very important use cases of NLP technology, essentially going through natural language text and finding semantically meaningful entities, finding the actors, the organizations, the locations, the entities, concepts, and relations between them in a way that is later accessible by a machine. So for instance, in the case of these 4 million documents, you want to be able to ask a tool like a search engine the question, is there a person's name or people's credit card numbers in any of those documents? There's no way you can formulate that query without natural language processing having analyzed the data and having marked up the occurrences of these types of entities inside your content. So how does that work? Essentially, when an NLP technology goes through content, what it ends up is some sort of, ideally, some sort of semantic representation of a sentence. When you look at the sentence on the screen, John Doe, the CEO of Acme Corp, announced a capital increase last week. When you read through that sentence, you will see that your own mind also kind of stops a little longer at some of the phrases that you see. I would guess that those are the key phrases that you detect on scanning through the sentence. And essentially, natural language processing enables a machine to do the same thing. If you just ingest the document in a search engine, it will just work with the individual tokens. So John and Doe, the and of and CEO would all have the same level of importance. But if you apply natural language processing, it can tell you that John Doe is actually a person. CEO is a job title, organization, Acme Corp. Capital increase is some sort of concept, and last week actually is a date. And having that additional semantic layer on top of the sentence now enables you to ask questions such as in the PII case, in the data breach case before, which documents contain a person's name? Which documents deal with Acme Corp, if you're dealing with a case matter regarding that organization? Which documents actually deal with capital increases? Which documents are dated somewhere in the last 6 months? Then that would actually be a part of that collection. You already need to apply NLP at a pretty sophisticated level to be able to get that information from the sentence and store it in a way that is accessible to you. At another level, again, bring the level of abstraction up to where we humans usually reason about documents. You could also say that person is just an instance of PRI, US PRI potentially, if you know that. Job title and organization are in a relationship with each other. It's a management relationship, essentially. The capital increase concept actually is in the group of financial actions or financial operations. And the date of last week is a relative one as opposed to an absolute date. So it's only valid if you have a reference date to resolve it against. So that is what I basically mean by increasing the level of abstraction, adding semantics to a document to make it more accessible for research and for producing the relevant data for a use case. That is exactly what our NLP technology, for instance, is doing, what other NLP frameworks are doing. They're looking at sentences that come in as string of words and turn them into something that is semantically annotated, that carries meaning, that abstracts from the pure surface token form to concepts that we as people can deal with and know, and that enable us to do more efficient workflows, to not ask 1,000 queries towards the search engine, but just one, not kind of read through 4 million documents, but actually only read through a report that an NLP tool ran on those documents, and that will list all the different types of personally identifiable information that is available in that document set. All right, so what is required to get there? It seems easy enough because a person kind of does it on the fly. When you read through that sentence, you basically created all these levels of abstraction in your head. You semantically tagged the sentence, if you will, while reading it. For a machine, you have to teach it a lot of stuff. And now there are many approaches to do natural language processing. Some of them are based on machine learning. Some of them are based much more on pre-built rules. But no matter what it's based on, you have to encode knowledge about natural language in the machine so that the machine can do the same analysis steps on these sentences that you would do as a human. So if you run natural language processing on a sentence such as this one, my flight departs from John F. Kennedy at 9 a.m., the first step would be to hack it into tokens, which is very obvious for us as humans, but a machine still has some trouble doing that. Well, even more trouble when it's Chinese or something like that, where you don't have spaces between the words. But then the individual tokens actually need to be fed into a tool called a part of speech tagger, which will then assign their part of speech, their kind of grammatical role to each of these tokens. So my is a possessive adjective. And as a human, again, for us, that's relatively natural. We have learned that in school. Maybe some of you even still remember what a possessive adjective is. Then a noun, a verb, preposition, a special noun, which is actually a first name, middle name, last name, a preposition again, and something that is unknown. So from the 9 a.m. part of the sentence, as part of speech tagger, cannot really tell you what that is because it's not a word. It's actually more like an abbreviation representing a time. But initially, a computer will not know that. It will know that this is basically the fundamental layer of information about these tokens that you just fed into it. Then an additional layer of natural language processing will come in and say, okay, certain sequences of these grammatical categories usually make up some form of semantic entity. So here is where we go from syntax to semantics. So the sequence first name, middle name, last name usually references a person, but if you have a good NLP package, it will also tell you that in this case, it could also just as well be a location because there's an airport in New York that is called John F. Kennedy, and most people just refer to it as JFK or John F. Kennedy without actually mentioning the airport part of it. So this could be a person or a location, and any decent NLP package will also tell you that the unknown token at the end structurally looks a lot like a time expression. Second layer of analysis. So now we have two semantic annotations that are ambiguous or uncertain. We don't know that if John F. Kennedy is a person or a location. We don't know for sure that the 9 a.m. is a time. It could just also be some other form of abbreviation. So in order to disambiguate that, we have to apply information that we can only derive from the context in which these words occur. And it's surprising for people who do this all the time when they communicate to others, how difficult that is for a machine to take context into account to get its bearings inside a sentence, even a simple one such as this one. But the knowledge that we need right now is knowledge about the verb in this sentence, which is departs. And a natural language package such as ours will then look up in its dictionary or in some other mechanism the semantic and syntactic properties of that verb, and will understand that departs usually governs 0 to 3 arguments. You usually depart from a location to location at a time. So with that knowledge, we can do a third pass across the sentence and understand that from the person and location ambiguous extraction, definitely this is the location because we depart from it. And it definitely makes sense to interpret the 9 a.m. as a time reference because we know that the verb of the sentence requires an expression or could require an expression of time. And you don't have to specify that all the time. Okay, so in this case, we applied 3 layers of linguistic analysis to arrive at our very basic semantic interpretation of that sentence. And that is essentially what we mean by processing it through natural language processing to annotate it with additional semantic categories which are closer to how we humans think and reason about documents. There is no such thing as general purpose NLP, at least not in my mind. Usually natural language processing is built and optimized to fulfill a certain task. You could think about a job search engine and what you want to do there. You could think about analyzing your stock portfolio and give you trade recommendations. Those are all use cases and goals that you can achieve potentially with natural language processing. So you first have to think about the use case. What use case do I want to solve? How do I usually go about it? And how can NLP help me? So in this case, what goal do you want to achieve? In job search, you want to handle combinatorial queries efficiently, which essentially is a grand way of saying you don't want to say CEO or CMO or CSO if you're just searching for an executive management position. In stock trading, you want to analyze news articles related to stock that is in your portfolio, so understand what's going on. And usually there's a manual way to achieving that. In job search, you would currently craft lengthy Boolean searches, such as the one I've shown you. In stock trading, you would read a newspaper and apply your own reasoning and analysis to make sense of it. But can make NLP that quicker, better, and less boring. Well, we've heard about that. By capturing the intention of your search with less effort, semantic analysis can definitely get you there. And in stock trading, the same thing. NLP can help you read through all those possible news sources and detect at least the organizations that represents the stock you should sell or not. Which technologies are necessary? Job search, entity extraction, query suggest, entity grouping, like we mentioned. In stock trading, it would be more like entity extraction than some analysis that gives you positive or negative sentiment about these articles. Is there currently technology that enables you to do that? In job search, evidently, yes. There are job search engines that do that apply natural language processing to achieve that. And therefore, we're able to enter the job search market with new technology that makes users' lives easier and therefore be successful. In stock trading, since sentiment analysis is not a problem that has been solved yet, really, in a good level, there's currently no technology that can help you do that. But both of these use cases are definitely cases for NLP where NLP would make your life easier and more fun. And the same is true for e-discovery. The same is true for data breach notification. The same is true for data subject access requests. All these use cases would be incredibly tedious to solve without natural language processing. How do you now use the semantic goodness that you just extracted to be better at finding stuff? I promised initially that this would make search engines better and would make it easier to access information. So this is a 100,000 documents, and I'm hoping I think you should see my browser window now. It's a 100,000 document from Wikipedia that we indexed into ayfie Inspector. And just by the fact that we indexed it into the search engine, you immediately get access to all the semantically meaningful entities in that document collection. So when you start typing a query where you would usually kind of have to think about how do I spell this and what terms could I actually be looking for, you immediately get suggestions about all the semantic meaningful entities and terms and concepts that occur in this document set. So if you start typing something like Kazab, you see here that it, for instance, under locations, it projects Casablanca. Under terms, it projects Casaba melon, then a lot of person names that are spelled like that. So now if you click on Casablanca, you get only the documents related to Casablanca in Wikipedia, and you get the corresponding terms and entities on the left-hand side that co-occur with Casablanca in these documents. And as you can see here, which is interesting, I now did a search for Casablanca, basically an old school search that returned 387 results. But the engine can tell you that only in 353, Casablanca has actually been semantically tagged as a location. In the other documents, it occurs as something else, which might be the name of the movie or might be some other form of using that word. So this is where this semantic information comes into play. And now, without even typing further queries, you can play with these semantic entities to further drill down and say, okay, I want all the documents that also mention Humphrey Bogart. But since I'm not interested in the movie per se, I'm going to exclude all the documents that mention Warner Brothers. And therefore, you kind of went from the 100,000 documents to 16 by interacting with the machine on a level, and I hope I made that clear through the presentation, that you usually don't interact with with a search engine. You're interacting with the search engine on a semantic level. You told it about entities and semantic annotations that you're interested in, much rather than telling it about terms that you want to find in your documents. And that semantic interaction with the search engine is enabled through natural language processing and enables a lot of very, very interesting workflows in many different areas where your work is just much quicker, much more effective, or just simply less tedious than with a traditional way of accessing that data. Obviously, if you're interested in that, I have to invite you to visit our website, ayfie.com, or contact me personally, and I'll can tell you more about it. But that's basically what we believe in. We believe in semantic interaction with data as opposed to poking around in it with simple token queries. Thank you.